Hello, Year 10s. Welcome to working with surds using rational and irrational parts and generally using surds in equations. I know surds look scary, everyone seems to be more comfortable working with indices, but right now we're just going to look at some examples of surds in equations and how to solve them. So, quite a common question, even though it seems like a strange one to be asked, is write in the form a plus b root 2, where a and b are, I actually don't know what the q is. Real? Normally we use R for real, but let's pretend they're real. So, a and b root 2. Now, here, clearly we're not in the form a plus b root 2, but a good starting step with these is to rationalize the denominator. So, 4 over 2 take root 2 multiplied by 2 plus root 2 over 2 plus root 2 is going to be 8 plus 4 root 2 over 4 take 2 is 2. Now, written like this, you can think of it as two parts. It's really 8 divided by 2 plus 4 root 2 over 2. Then 8 divided by 2 is 4 plus 2 root 2. So therefore, this here is our A, this here is our B. Alright, take this one to one side. Multiply by 1 take root 2 over 1 take root 2. Pretend that's a square root sign. That will be minus 5 plus 5 root 2 over, now 1 take 2 is negative 1, so this then becomes positive 5 take 5 root 2, where this is our A and negative 5 is our B. Alright, now that just seems like algebraic gym, and it is, but that becomes useful later on when we do more complex equations. And here's an example of it. The question is, solve for a and b, given that a is greater than 0. Alright, a couple of ways to go about this. We could expand out this, remembering that we would use FOIL and not kill kittens while doing it. I would advise against doing that because you'll end up with a 2ab term in the middle. You genuinely don't want to multiply the number of unknowns you have. If you have just one a at the moment and one b, you don't really want to multiply them. So instead, we're going to square root the other side. Actually, I lied. Let's go with plan A and expand that out. Apologies. A plus b root 2, a plus b root 2 equals 3 plus 2 root 2. What we're aiming for is to write it in the form a plus b root 2. And that way we'll be able to see, well, the a is the 3, the b is the 2. Might not be that easy, but that's where we're going. A squared plus a b root 2, and that's going to happen twice, plus 2b squared equals 3 plus 2 root 2. You can check that FOIL expansion if you want. Now let's consider which part is real, which part is imaginary, which part is irrational. Sorry, which part is rational, which part is irrational. The rational part is this. The irrational part is the part associated with root 2. So what we can say is that a squared plus 2b squared equals 3, and similarly 2ab is equal to 2. Alright, now where to go from here? Well, we are solving substitute by solving simultaneous equations. If they look a little strange, the best way forward is by substitution. So taking the second equation, I can eliminate both of them and say that AB equals 1 or A equals 1 on B. Then substitute into the other equation. So if A equals 1 on B, I can write, instead of A squared, I can write 1 on B squared plus 2B squared is equal to 3. Alright, now, so where to go from here? Well, we can recall that this is really the same as, this squared applies to both in there, so it can be written as 1 squared, which is 1 over b squared. So 1 over b squared plus 2b squared equals 3. Ugly. We feel like it's a bit of a quadratic, but there's that 1 on b squared we don't like. So we're going to multiply both sides by b squared to get it on a single line. If you don't know what to do, get rid of the fraction is a very good way to start. So if we multiply everything by b squared, we get 1 plus 2b to the 4 equals 3b squared. Looks scary, especially because we haven't had much practice at solving quartics, powers of 4. But I'll rearrange it like this. 2b to the 4 minus 3b squared plus 1 equals 0. Now, normally we'd be in a lot of trouble here, but note there are only even powers. So we're going to pull a cool trick. We're going to say, let x equal b squared. Let's see what happens after we make that substitution, and we have done this trick before. Recalling that b to the 4 is really the same as b to the 2 to the 2. If we're letting x be b squared, then b to the 4 is really the same as x squared. So 2b to the 4 is 2x squared minus 3x plus 1 equals 0. So our very scary quartic with powers of 4 from this substitution, or this little trick, now has turned into a quadratic. Let's see. Can we factorize this? Really hope so, or this is going to get ugly. 2, neg 3, 2. You can use whatever method you want to factorize, remember. This will be neg 1, neg 2, 2, 1, neg 1, neg 1. So this factorizes to x, take 1, and 2x, take 1. Alright, so our solutions, if that equals 0, are x equals 1 or x equals a half. So what we're really saying is that b squared equals 1 or b squared equals a half. So, two options here. If b squared is 1 or b squared is a half, then b is either plus or minus 1, or b is plus or minus 1 over root 2. Now, let's see what we can do as far as solving for a goes. We'll recall that a is equal to 1 on b. And we'll recall that a is greater than 0. So we're only going to consider solutions where a is bigger than 0. Here, if we substitute a negative into this equation, it'll come up with a is negative. So if we substitute a negative for b in, it'll come up as negative for a. So we're going to ignore the negative solutions. So we'll say quite clearly, ignore minus 1 and negative 1 on root 2 as a is greater than 0. So our two solutions are b equals 1, in which case a will also equal 1, or b equals 1 on root 2, in which case a will equal 1 on root 1 divided by 1 on root 2 will be root 2. Alright, I do have, now that's quite a hefty example, look at that. So, running through the steps again. We expanded this out. The reason I expanded that out rather than square rooting the other side is because I just tried square rooting the other side and it doesn't go anywhere. So, expand it out. Then the most important part is being able to equate the rational and the irrational. So yellow here is rational, green irrational. Form two separate equations. From there, it takes some work. But the more type of practice we do with these type of difficult problems, the better you'll get at understanding what to do. So, rearrange for one equation, substitute, then solve. And solving took a bit of work and a neat trick with the replacement. And, believe it or not, I have two more similar questions. By all means, have a go at them yourself. Otherwise, I will show you how to do them in class. Alright, thank you very much. Sorry this is such a long one.